So we're going into trig, and then there is a phrase that you need to know. SOHCAHTOA. I write SOHCAHTOA to help me remember my 6 trig functions. Since this starts with the S, this one represents the sine trig function. Starting with the C, this represents the cosine trig function. And since this one starts with the T, this represents the tangent trig function. So sine, cosine, and tangent. These all have to do with angles. So the symbol that we use for angle is theta. So sine of theta, sine of an angle, cosine of theta, cosine of whatever angle I tell you, and then tangent of theta, tangent of the angle I'm going to tell you. So the S says sine equals, this is supposed to represent a ratio. The O represents opposite, and the H represents hypotenuse. If we're talking about hypotenuse, that means that these 6 trig functions help us with right triangles. Cosine has its own ratio. A stands for adjacent, and H stands for hypotenuse. And tangent has its own ratio. O stands for opposite, and A stands for adjacent. Now we do shorthand these. Instead of opposite, we'll write op. Instead of hypotenuse, we'll write hype. Instead of adjacent, we'll write the ADJ. So we do have 3. There are 3 more. There are a total of 6 trig functions, and the other 3 are reciprocals of the 3 that you already have. If you remember, reciprocal said that the fraction flipped. So the reciprocal of sine is cosecant, and we're still talking about the angle. So the reciprocal of sine is cosecant. Cosecant is the reciprocal of this. So we are talking about hypotenuse over opposite. The reciprocal of cosine is secant, and since it is a reciprocal, that meant the fraction flipped, so it's hypotenuse over adjacent. And the reciprocal of tangent is cotangent, and since it's a reciprocal, that he is going to be adjacent over opposite. So we have 6 different trig functions that we are going to be using on the right triangles. A right triangle will always tell you which one is the right angle. As you recall, the right angle always stares across at the hypotenuse. So whatever side is opposite of the right angle is always going to end up being the hypotenuse. To determine which is adjacent and which is opposite, you have to look at whichever angle theta you're told to. So if we are told that this is the angle theta right here, he determines which is opposite and which is adjacent. So opposite would be right across from him, and adjacent is the side right next to him that wasn't already claimed. So this side would be the adjacent. So let's pretend that we actually chose the other angle instead. Theta's not here, theta is here now. It does not change which one is the hypotenuse. The hypotenuse is always the side exactly opposite the right angle. Theta just changes which one is opposite for the particular angle in question, and which one is adjacent to the particular question angle. So the theta tells us who is opposite and who is adjacent. So we're given a problem. We're asked to identify the 6 trig ratios, and this is our right triangle. I noticed that I only have 2 of the 3 sides. Because it is a right triangle, we know that we are allowed to use a squared plus b squared equals c squared to find the missing third. The missing third is directly across, which meant he is our hypotenuse, which is always c. So I have my A and I have my B, and my job now is to find the missing C. So we're going to go ahead and solve for C. So I just found C to be 13. So this missing hypotenuse is going to be a length of 13. So now I need to find my 6 trig ratios. I remember SOHCAHTOA. So represented sine of the angle theta that we are looking for, and O represented the opposite, H represented the hypotenuse. If that was sine, he had a reciprocal, which was cosecant. Reciprocal said to flip the fraction, so his reciprocal, cosecant, is going to be hypotenuse over opposite. So if I need opposite, I need to look at my theta. The thing directly across, the side directly across from theta is my opposite, which meant the side directly next to is going to be the adjacent. So I needed my opposite. My opposite was 12. I needed my hypotenuse. My hypotenuse was 13. The reciprocal of sine is cosecant. The reciprocal of the sine's fraction is 13 over 2. 13 was the hypotenuse. 12 was the opposite. C, c, stands for cosine of the angle theta. This AH represents adjacent over hypotenuse. Adjacent is the 5. Hypotenuse is the 13. He also has a reciprocal fraction. Cosine's reciprocal is secant of the angle theta. If I reciprocal this, it is hypotenuse over adjacent. The hypotenuse was 13. The adjacent was 5. And I notice it's also the reciprocal of the cosine's fraction. Our last one is tangent, TOA. TOA goes for tangent of theta. O stands for opposite. A stands for adjacent. My opposite is 12. My adjacent was 5. He also has a reciprocal. The reciprocal of tangent is cotangent of the angle theta. The reciprocal of that is adjacent over opposite. By reciprocal, I have 5 over 12. 5 was the adjacent side. 12 was the opposite side. And those are my 6 ratios. Our next problem, they're being asked to identify the 6 trig ratios. I have a right triangle, which you have to have a right triangle to use the trig ratios. This is a 3-4 triangle. From geometry, you might remember that this is a 3-4-5 right triangle. If you don't remember that from geometry, then you're going to have to use a squared plus b squared equals c squared to find the missing hypotenuse. The hypotenuse is always the side directly across from the right angle, so this is our hypotenuse. So this would have been 3 squared plus 4 squared equaled, we didn't know at the time, squared. And then you're going to solve for c. So you could either solve for c to find it was 5, or you remembered your geometry, 3, 4, 5 is a right triangle. So now we're being asked to find the 6 trig ratios. So I have SO, CA, TOA. That helps me remember that sine of theta is opposite over hypotenuse. That also helps me to remember that cosecant is its reciprocal, and cosecant is hypotenuse over opposite. CA helps me to remember that cosine of my angle theta is adjacent over hypotenuse. It also helps me to remember that his reciprocal fraction is secant of theta, which is going to be hypotenuse over adjacent. TOA helps me remember that it is tangent of theta over A, tells me it's opposite over adjacent. And then his reciprocal is cotangent of theta, which would be adjacent over opposite. These are all the helping tools. Now I just need to go through my right triangle and I need to find my fractions. Opposite, we weren't given a theta, because I forgot to put it. Theta was this angle right here. So here is my theta. Directly across from theta is going to be my opposite, and the one immediately right next to it is going to be my adjacent. So I need my opposite, which is 3, and I need my hypotenuse, which was 5. These two fractions are reciprocals of one another, meaning they got flipped. I need adjacent, which is 4, and I need hypotenuse, which is 5. These two fractions are reciprocals of one another. Tangent, I need my opposite, which is 3, and my adjacent, which is 4. These are reciprocals of each other.